In this video, we're going to talk about the Python Pandas time series data. As we know, time series is very often used in data analysis. So the basic structure is the daytime will be used as index, and it's a kind of like a special type of data, and it's often used. Pandas, you have in Pandas there is a daytime 64 can be interpreted as a string or daytime or lumpy daytime objects. So here is an example. We can create to a daytime. We can create something like this. You have a daytime string, different format, and then daytime, just the Python, just the regular daytime data type, or LongPy daytime, and then different shape, different type of different structure. It will eventually be formatted the same daytime. So when you run this, you're gonna get this results. So that will be actually the same daytime. Once you have that, you can actually format it to any daytime that you are interested. For example, this will be format. The format of this is actually a year, day, and a month. So we can do year, day, and a month. And this will be translated to year, month, day. So that will be a regular daytime 64 data type. And the hours, if you have hours or minutes, it's also can be formatted. So like we have this data has hours and minutes, so you can put H and M. Here M is uppercase M. It means it's minutes, not a month. The creating a daytime sequence uses fixed intervals. D for daytime, W for week, M for month, and so that will be the parameters. So here is the B1 is actually a random number. From it's a random number, and then we're going to make roughly about 30 random numbers. And then for B2, we're going to do the daytime. We're going to do the day range from 2020 June 1st, and with a period of 30, and then the frequency is 1 day. And then here's the date, how the day look like, and we can actually combine the two things together. The index will becomes the date, and the data will actually be the B1, the random numbers. So the M will look like this when you actually show df when the M, the value of M. So this is it's like a dictionary, right? It's like a dictionary. So you have the key and the value. So M is like it's basically like a key, and this is like a series. So we have daytime as a index. So once we have that, you can actually create a different type of data, daytime data, time series data. So B3 is a random number, and B4 is again the 52 weeks, and then DF will be have B3 and index as B4. So in this one, we didn't specify what is the column's name, and that will be a default 0. So so we can slice the DF data frame by using the dates. So starting from July 10th and ends at July 28th. So, and the data frame can be in this case alternative to the periods. You can give start and stop dates, and then the frequency will be the m supposed to be the month. So in this one, B3 will be basically is every month, every end of the month, and the dates index to and from of CSV files. So we can actually get a round of D1 NP round. So this is the 6 plus 4 times AP random number from 7, and then the decimal will be the 2. So we have D1 and then D2 will be basically random integer. So that will be your alpha, beta, and then D3 will be actually the day range, and it's 1 day starting from 2020 May 29th, and the period is 7 days. And the DF now it's formed as alpha and beta. So that's the column, and that's another column, alpha and beta, and D1, D2. So you have index as the dates. So eventually will form a day time series like this. And for the DF, for the data frame, you can also directly read from a CSV file. So simply just use read.csv, and then you have the CSV file name, and for the index column starting from 0. So that will give you the results. So you print it out. That will be str as a string. It's the type of index number 2 is going to be a string, and the class of the pandas, so it's going to be timestamp. And then you get df as index. You actually get from the pandas to daytime, you have df index, which is the time series, and you format it as year, month, and day, and that will be your new df index, and then you print out the type of df. That's going to be the timestamp right here, and then df, see, this is the slicing of df. So from the beginning to the end of 2020 May 31st, that will give you the results right here. Okay. To construct the dates from multiple columns, if we want to construct a data like this, we can actually first generate some years, and then months, days, and data. So we construct all of those, so it's going to look like this. And then we can form the df as data frame. So year will be that M and D. And then we can create a df as a new df. It's formatted as a timestamp. And then we can create a series of added data. So as df2, then we can concatenate the two things together. So df1 and df2, that will be the concatenation. So that will be df1, that will be df2. So all those column, that's column is df2, this is df1. When we want to actually use the rows and the columns in df in pandas, we can actually use the pivots. You can specify that. So for example, we read a data from the CSV file as df, and then df, we can get the t, flip the rows and the columns by using the transpose. It's called a pivot. So we transpose the rows and the columns, so that will give us the correct ones. So that will be a time series. And the other part is the date arithmetic. Suppose we have daytime, we have timestamp right there as a time appointment. we can retrieve the date. We can also delayed. We can add two delta times delta 2 days. We can add 2 days. We can add 2 days to this one, and that will be Saturday. And we can actually we can also do temp delta days equals to 2. That will be the same. And then we can also do some offset of the day. We can do offset of day, so it's postponed 2 days. What if it's a business 2 days? That will be actually business day. Offset B day, that will be business day. So that will be Monday. So this is the basic operation of time series about time, and we're going to cover a little bit more for the time series in next video.